In this video, I will talk about Kirchhoff's law. When do we use Kirchhoff's law? There are many instances, there are many situations where you cannot solve the problem either by using series combination of resistor or parallel combination of resistor. That is the situation. And if you have to solve or if you have to find the current in a particular resistor or the voltage drop across a or a voltage drop across a particular resistor, then you can use Kirchhoff's law to find the current or find the voltage drop across a resistor or capacitor or any electrical component. So for example, here we have like two circuits here, this circuit and this circuit. And these circuits cannot be analyzed either by using the series combination or parallel combination or both. And you see here there are multiple the voltage applied here. So solving this one by series or parallel combination will not work at all. So in that situation, we're going to use the Kirchhoff's law. Or in fact, you may use the Kirchhoff's law even for the simple combination of series and parallel combination of resistor or capacitor or resistor and capacitor. So this one works for almost for any circuit. So now let's talk about what is Kirchhoff's rule. There are two rules. The first rule, that is called the junction rule. What is the junction rule here is the sum of all currents at any junction is zero. That means if I look at this junction here, so this is a circuit here, and if I look at this junction, the total current at this junction is zero. What does it mean? It means we take the incoming current as positive and the outgoing current as negative. So incoming current and outgoing current. So the total current at any junction is zero. What we call the sum of all current at any junction is zero. In this case, all the current that is coming towards the junction is regarded as positive, and all the currents that is leaving the junction, for example this current I2 and I1, is regarded as negative. So let's apply the Kirchhoff's junction rule or Kirchhoff's current rule at this junction 1. So at junction 1, you see I is going towards the junction, so it is positive. This is leaving the junction, so it is negative. This one is also going away from the junction, so this is negative. So all together it has to be equal to 0. And I can also rearrange it as I, if I take to the other side and take to the other side, I'll get I1 plus I2. What is I? The I is incoming current. I1 plus I2 are the outgoing current. So this law now becomes further more simpler, that incoming current is equal to all the outgoing currents. All the incoming currents has to be equal to the outgoing current. So now let's look at the junction rule at this junction 2. At this junction 2, we have again I2 as an incoming current, I3 and I4 as an outgoing current. So I2 has to be equal to I3 plus I4. So this is the Kirchhoff's junction rule here. See, that's what it is. So this is so far the Kirchhoff's first rule. Now let's talk about Kirchhoff's second rule, that we also call the voltage rule or the loop rule. And this is the most important of it. What does it say? If you look at any closed loop, so for example here, so this is the one closed loop. If I look in this closed loop, the total voltage in this closed loop has to be equal to 0. So the sum of all the voltage in a closed loop must be 0. So how many loops are here? So I can consider this as one loop. I have this as another loop. So the total voltage in this closed loop must be equal to 0, or even this one is one loop here. So the total voltage in this loop again must be equal to 0. So, but there are some sign convention you have to follow. When I say sign convention, then you have to regard certain direction as a positive and the other direction as a negative. So first thing, what you have to do whenever we're solving the Kirchhoff's rule, you have to assign the travel or the loop direction. For example, in this case, I can consider this as a loop direction. Okay, so here as this direction, or I can consider this opposite way this as a loop direction. So you may choose loop direction either clockwise or anti-clockwise. It's entirely up to you. Okay, you may call this direction this way, or you may choose this way. It's entirely up to you. You're choosing the loop direction, that we also call the travel direction, is entirely up to you. Okay, so if you considering the battery, if you have a battery and this is the travel direction or the loop direction, you see, for a battery it is going from negative to positive, then the potential difference or for the battery is regarded as positive. If opposite happens, if for the battery this is positive and this is negative, if it is going from positive to negative, the loop or the travel, then we regard this one as a negative. And here are the sign convention for the resistors. So in this case, so you see this is my travel direction and the current is going in the opposite way. So in this case, as the current and the travel are in opposite direction, the potential drop across the resistor is considered positive. The delta V here is the potential drop, RES stands for resistor. So this is positive. And if the travel direction and the current direction are in the same direction, then the potential drop across this one is considered negative. So if you follow these two rules, the very simple Kirchhoff's first rule and the second rule, you should be able to solve almost any kind of complicated problem at this level. Okay, so now let me give you a little bit hint here. So let's consider one loop here. First thing you have to do, you have to choose a loop direction. So you tell me here, let's say I'm just choosing this as my loop direction. Okay, now this is my loop direction here. Now look at the battery here. This is positive and this is negative, and the travel direction is going from negative to positive. So how do you write down the Kirchhoff's law? The way you will write down here, I'm just going to write down this side here. For the battery is the V, it should be positive here because this is going from negative to positive. And now I have chosen the current in this direction, current. And in this case, for this resistor, the current is going downwards here. All right, the current is going downwards and the loop direction is also in the same direction. The current and the loop direction are in the same direction. So that means we have to take as a negative, and the voltage across the resistor is I1 times R1. So I just simply write I1 times R1. This has to be equal to 0. So that's how I write down the loop equation for this loop here. You may do the similar thing for this loop here. and I will explain this one in the next video with the numerical examples here. So this is it for the Kirchhoff's voltage and the current loop here. And this is a very simple thing. All you have to do, follow the sign convention. If you have any questions regarding the Kirchhoff's laws, write down your questions in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you very much.